Okay, so this is definitely a lesson that's intended to be taught over more than one day. And I haven't really decided how I want to break it apart. It's possible we're going to get through everything today. And if we do, our homework would probably be like right at the end of the hour. And then it's not something I guess I would expect to be done by class tomorrow, I guess. So my plan for the win times usually is to try to teach you something and then give you some time to work and try to go from there. But it's just worked out really bad the last 2 weeks that, like, say, last week was a really long lesson to teach, and then kind of the same for this one. So we're technically still in the same chapter. I mean, like, it's a new unit, I guess you'd want to call it. Everything up until 8.5 was on rationals. That's why we split it apart like this. So the first test was on everything with fractions. The second test is everything on radicals. It's going to be very short. So it's only going to be 3 sections. We have 8.6, 8.7, 8.8. And so it's going to go by really fast. But having said that, we have such a really weird couple weeks of school coming up. Like, we had the ACT day yesterday, so there was nothing on that day. And I wasn't going to sign anything because half of you guys had to take the ACT. So then we've got WIN day today, tomorrow. Friday's a regular school day. Monday you have off because it's a workshop. Tuesday is a regular school day. And then next week on the WIN days is MCA math testing, which is also juniors. So it's kind of a rough couple weeks for you guys. We'll have more details for you. Our hope is that you can get the whole MCA test done in that one WIN period. It's not in the morning WIN sessions, it's during class. They're giving it during math classes this year, partially because, like, the other subjects got upset they always had to give it. I get it. It's just weird for our class because we're not all juniors. So, let's see, what period is this? 2? Yes. So I have to proctor it second period, which means 11th graders are going to be in this room taking the MCA test. So there's a good chance all the juniors in here would stay in here to take your test. All the non-juniors, which, if I remember correct, is like half of you. How many are not juniors? Yep, okay. So the other half of you are going to be assigned to some random math room that is not giving the MCA test. And yeah, that's the part we don't know yet, to be honest. We have to figure that one out. Juniors are all like placed, and they all have a location to go to. Non-juniors, not yet. I do have something for the non-juniors to do that particular class day, but it's not necessarily an assignment. So are you a junior? Then no. MCA tests go by what grade you're in. 10th graders have a test too. Science, maybe? English? Okay. Oh yeah, I think 9th grade is the science and writing, maybe? What did you get? You guys didn't take them last year, did you?
I think we learned biology in the science one.
Yeah, the science one is in 9th grade for sure. I know there's 2 different English ones. One's reading, one's writing. I think one's 9th grade, one's 10th grade. And then the math one's 11th grade. I mean, other than that, I really only know the math one because I'll be honest, that's the only one that really matters to me. So, the other subjects, I think maybe what you're asking though too, the other subjects aren't on the same day. So like the 10th grade test, whichever one that is not necessarily that day. I don't even know what days those are set up because they've just been kind of setting it up as the year goes on. But either way, what I was trying to say with that whole thing, we only have 3 sections, but our next 2 weeks are really messed up. And so it's going to be really hard to have kind of a fluid, learn a topic, take a test on the topic. We'll do the best we can. It's really hard for me to come up with a schedule, to be honest. So maybe you'll call it good news. I don't know what you want to call it. I believe there's only 2 weeks after that calendar for the end of the school year. So there's only 7 weeks left.
So we have how many more units in class?
Oh, so we have this unit test, and then the next one we go to is 9. And then depending on when we finish 9, it will depend on if we are able to get to 13, which is on trig. It kind of just all depends on how long everything takes because there's so many messed up days. This year has felt super long with all sorts of different kinds of days. So anyway, we've got a lot of notes from this section. I'm not just going to overload you on it though, so most likely what's going to happen is we'll take notes today and you'll have tomorrow to work on it. Friday. Yeah. The next class day. My guess is that's what's going to end up happening. Otherwise, if you guys want, I can always stop partway through the hour, and then I'll give you the homework, and you can work on whatever part of the homework you're able to do yet, too. So I'm okay with whatever option works for you. Like if you're feeling pretty worn down mentally, we can decide that, too. Okay, so a radical expression is just basically anything that has a root symbol. You guys are most used to square roots. But technically there's a root for whatever root you want. Is that green kind of hard to read for you guys on the smartboard? No? Yeah? Like for me it kind of is. It's kind of weird. It comes up very different on a computer screen than the smartboard. These notes I wrote for distance learning last year, I think, if I remember right. Or a handful of years ago or whatever it was. And so I tried to have a black background for most of distance learning things because everybody was basically laying in bed with their lights off. And so I got complaints whenever we had a white background. Everybody was feeling blinded. Yeah, now there is a lot of words up here, like terms. It's okay if you don't flat out know them. I'm putting them up there so that if you hear me say it, you can just recognize it or, kind of put it together. What is written down in green at the bottom, is that what you're having trouble seeing? What's written down in green at the bottom, it's basically helpful to know. It's not like something you have to have, I shouldn't say not have to have memorized. You're going to end up learning it very fast regardless because you kind of know some things already, and as we do problems, you'll just kind of learn it as part of the problem. This one has a huge asterisk by it. And I'll explain it, and it's super annoying. It matters how the question is presented. Oh my gosh, there's so much sniffing in the room today. What happened? Everybody took their sort of day off and got sick? Okay, I'm guessing most of you are getting pretty close to done writing if you haven't already. So the bottom one of these three is probably the one that you understand for sure. Basically, the square root of a negative number is imaginary. So that's 0 real solutions. I should have put the word real in there. We've done cube roots a little bit. Like cube root of 8 is 2. And then you can have cube roots of negative numbers. So like cube root of negative 27 is 3. Negative 3. But cube roots only have a single solution every time, no matter what. Even roots, I'll just use square root as an example because that's what you're used to. It 100% depends on how it's presented to you. If something is written down like this, like if it just says square root of 9, the answer is not plus and minus 3. The answer is 3. If something says, if the problem is presented like that from the start, if it says any number, some number squared is 9, okay? So the way this is presented, this answer could be plus or minus 3. The plus or minus is usually designated in the root symbol. Like if they want the negative version of the answer, they'll usually put a negative symbol in the front. So this would be the positive square root of 9. This would be the negative square root of 9. So square roots do have two answers, but it's very big on details. And that's not always fun for you as a student because the way the question is presented could have different kinds of answers. So just know that even roots do have two versions, positive and negative. But if the root symbol is there already, you generally don't write both. They usually will have a symbol in the front designating which one of the two that you're supposed to answer. If it's an equation and there's a squared, then it's going to have both answers. And it's kind of, it's a detail I don't necessarily like as a teacher. I understand it, but it's hard presenting it to you as a student because they both seem like they're pretty much saying the same thing. So just know that we'll deal with that as we go through. So let's try some. So we've got 3 examples, and these are obviously what's just written out as words. the fourth root of 81, the cube root of negative 125, the sixth root of negative 729. Please know that I'm not expecting you to know the sixth root of 729. I 100% myself do not know it. I'm going to guess it's 3, but who knows? $27 times 27 seems like it could be big enough to be 729. Okay, should we go to the easiest one first? My guess is you guys probably think B is the easiest. Cube root of negative 125. So that would mean what number times itself 3 times would give you 125, or negative 125. It's going to be negative 5. And that's because negative 5 times negative 5 times negative 5 would be negative 125. Now, would you like to know how to type that in your calculator to find it out? Okay? So your calculators will most likely have a button on it that looks something like this. If you have a scientific calculator, it's usually like above a button. It'll say X root Y. That's probably how it's written. On the graphing calculator, it's not directly on a, you have to get there. On the graphing calculators, you're going to hit the math button. And then I think it's like the 4th or 5th one down, it says X root Y. Is that right? Just kind of remember that off the top of my head. Yeah. Now, there actually even is a cube root button on the graphing calculators that you could use too. Here's the annoying part about this button, is you can't hit the button first. The X is supposed to be the first number typed in. So on your calculator, to find this answer, we're going to have to type 3 first to designate to the calculator it's going to be cube root. Then you hit the X root Y button, and then you're going to hit negative 125, probably in parentheses. I don't even know if you'd need to, but who knows. And each calculator shows it different. I think of the graphing calculator, it might put the 3 in the root symbol. Yeah, scientific calculators probably won't. Yeah. But either way, this should give you negative 5 as an answer. Is that correct? Okay. Did anybody not get negative 5 that was trying to? So my guess is you're going to be using the calculator a lot. So
It's getting like 2 point, all these numbers.
did you hit the 3 first?
Yeah.
Okay. Oh, you might not have hit the second button.
Oh, I did.
Yeah, so you probably ended up doing like square root or something like that. Yeah, and that's kind of the problem, is that every single calculator is different, that I can't just tell you what buttons to push. Okay, 4th root of 81. Now, some of you might be able to do this in your head, and if you can, that's awesome. Like the way I'm figuring this out is I know that 81 is 9 times 9. And if I break down each 9, that would be 3 times 3 times 3 times 3. So if you 3 4 times. So I know the answer is going to be 3. Now this may be looking for the answer to be plus or minus 3. I'm not going to be super picky on this because it can be written so differently. But if you want to know how to type this in your calculator, you're going to have to do the 4 first, because that would be the 4th root. And then this X root Y button. And then 81. And then anytime there's negatives involved, just make sure you use parentheses. How are we doing at coming up with things? I know this is just kind of the introduction of roots, of all different roots. Because I'm guessing most of you have only done square roots and cube roots. Did anybody figure out the bottom one yet?
Said error.
It said error. Perfect. That's what I was looking for. So, typing this in the calculator, 6 root of negative 729. If it says error, some of your calculators might actually give the answer as an imaginary one. Most of them probably say syntax error. Oh, actually, I bet the graphing calculators say non-real result. What did yours say?
Mine says 2 point, a bunch of numbers, but 1.5i.
Okay, so your calculator is already in complex mode, which is not bad. So hit the mode button on the top of your calculator. I think it's right underneath the F2 or F. It's towards the top. There's a button that says mode. And then, do you already have the mode up?
Yeah.
Oh, okay. One of the lines will say complex and real. Like it'll say real complex A plus BI. So make sure it just says real.
Change it?
Yeah, it'll probably work easier if it's not in imaginary mode, because we're not dealing with imaginaries right now. Okay, does anybody remember why this one shouldn't have an actual answer?
Even roots of a negative number will always have.
Yeah, so the fact is you can't multiply something an even number of times and get a negative number. So this one has no solution. If you want to say imaginary, go for it. There's different ways you can phrase this. What happens if I try to do the highlighter on a black background? Oh, well, I mean, I guess it works. Are we feeling okay on these? Do you guys want to just try these 3 real quick? You don't necessarily even have to write them down. You just figure out the answers. They sure gave you a lot of strawberries in that one.
Oh, I got extra.
Oh, I didn't even know that was an option.
What does it have use to find it?
So that one right there. Oh, yours is backwards. Y root x. Let me see if it's set up backwards.
Because I didn't get the same things.
Yours is set up backwards. So x is usually the number you type in first.
Okay.
So if we want to do cube root of 8, I'm thinking you have to do the 8 first, and then say cube root. Yeah, interesting.
So just do it backwards?
Yeah,
Or do I use my computer instead?
either one.
Okay.
I wonder if that's like a European thing to type it in.
Probably.
Do either of you guys have an iPhone? I'm kind of curious. On the calculator.
Okay.
Which one do you press when you're trying to find out the answer? Is it this one right here?
I can't read that.
X code.
Yes, so hit the number that you want the root of first. Yep. Yep, there you go.
Okay.
When you turn it sideways, oh, your X is on the inside of the root too first. Does yours have, yours says the Y is on the outside of the root? Interesting. I've never run into that before. If you're using the iPhone calculator, the order that you type them in is backwards. So whenever there's like an X and a Y in a button that you use, the X is the first number. And Apparently the iPhone one is set up backwards. It's kind of interesting. Yeah.
I would plug in 45 on this calculator. Because I did second and then this button, but it just is one square.
You have to hit the 4 first,
So 4 and then
and then the X root.
still not in the X.
Oh, that's okay. It still reads it correct.
Oh, okay.
So now put negative 256 in parentheses. And it should say error. Yeah, okay. So it just doesn't put the 4 as the root. But if you're typing it first, it'll know that. How are we coming? Kyla. What'd you get for the first one? You got error. How come? It's an even root of a negative number, so this would be no solution. Okay, good. Basically, I just want you to learn however your calculator is going to say it so that you understand what it means. So no solution for us is going to be imaginary numbers. Kyla, who are you going to choose for the B? Okay, Ella, I guess.
I got one.
You got 1. Does that seem wrong? Did you get that one without even using the calculator? Oh. So 1 is the weird one because no matter how many times you multiply 1, the answer is still 1. So like 1 to the 10th power is still 1. And so no matter what root you're taking, whatever root of 1, the answer is 1. Okay, Ella, next person, please. Oh, did you say Drew?
Yeah.
I see you guys are branching real far out.
Yeah.
C, what'd you get for that one? Cube root of 125. 5, excellent. Now, I will tell you right now that virtually every answer you guys are going to get is probably going to be in the single digits. You're not going to get something that's really big, most likely. But I'm kind of teaching you how to use the calculator because I also know that there's some of these that are they're just really big, and you're not expected to just know them off the top of your head. Okay. Now, these you might already know. I wanted to put them up here in case you didn't. So I'm pretty sure we've practiced this with square roots. But this is just telling you that it works for any root. It doesn't have to be just square roots. So the first one that's written in green is basically telling you that if you have 2 of the same roots being multiplied, you could combine them together as a single root if you wanted to. Or you could take a single root apart. And then the one in pink is kind of the exact same thing, just with division. If you're dividing 2 of the same roots, you can write them as a single root with the division on the inside. So sometimes these properties would help us simplify things, I guess. And this is where it's going to stop being helpful to have a calculator. Although some of you, does anybody have a Casio calculator? I feel like the Casio calculators will simplify these correctly. Some of the calculators work correctly for this topic, some don't. I know the Texas Instruments usually don't. The graphing calculators for sure do not. So that example that I wrote in top on the white, where it says cube root of 16, you can break it apart and write it as cube root of 8 and cube root of 2, and so your answer is 2 cube root of 2. Well, if you type in cube root of 16 on your calculator, it's just going to give you a decimal, most likely. Some calculators will tell you 2 cube root 2. Has anybody typed it in Desmos yet? I'm assuming Desmos would give you a decimal as well. Honestly, I don't use Desmos for calculating, so I haven't tried. Decimal? Yeah, okay. I assume so. There definitely are calculators that will actually do this and simplify. Usually they are the ones that are not allowed on the ACT or MCA. We need a nice bright color that is not green or that kind of looks like Pepto-Bismol pink to me. Yellow? Sure. Drew, how about this? Instead of giving you responsibility of picking the next person, do you want to just give me 2 numbers? 1 through 4 and 1 through 9. Or is that harder? She already went. That's why I thought numbers might be easier. Rather than, basically it's like rolling, but yeah, just pick 2 numbers. 3, 6. 1, 2, 3, 4, 5, 6. Anna. So I pointed to cube root of 8 right there. If my original problem started with cube root of 16, why did I decide to break it up into 8 and 2? Why didn't I break it up into 4 and 4? I think you were answering it the first time anyway.
Well, I was just gonna say, because 8 times 2 is 16.
Oh.
I was gonna say, but,
Well, that's still correct. Not why I chose 8 and 2 though. Right. So I chose.
They're different, and you don't want ones that are the same. Like, you don't want both 4 and 4.
No, not a bad thought though. Does anybody know why I'm asking that? Why did I choose cube root of 8 and cube root of 2 instead of cube root of 4 and cube root of 4?
Because one of the roots is simplified already.
I think you mean that correct. Cube root of 8 is a perfect root. So the answer works out nicely to 2. If I would have broken this up into cube root of 4 and cube root of 4, neither one of those answers is any good. Like, they're both just decimals on their own. So if you're trying to simplify roots, we are purposely trying to break it up into perfect roots, if we can. So if cube root of 16 didn't have a perfect root in it, I wouldn't even break it apart. I would just leave it as cube root of 16. So simplifying only works if you can take out something that works nicely. Are you trying to ask something? Okay. The bottom one, honestly, I didn't even have to break the bottom one apart, but I just did to show you that you can calculate the top and bottom separate if you want. You don't have to. Some people just do that in their head, and they know both numbers anyway. Okay, so we're going to try some problems from this. Cube root of 27x to the 7th. This feels like a big jump. Cube root of 27x to the 7th. Now I'm going to show you the long way to do this at first. And the reason I'm going to show you the long way is because this is how you would approach to do it in your head. And after doing some of these, you generally can do these same steps in your head and go right to the final answer. Wait, what time are we at? 10:47? We get out at 11:31. Oh yeah, we're doing. Although we're only on example 2. Something tells me we probably should stop midway during this hour for you to be able to start your homework, because I don't know if we're even going to finish the notes anyway. I don't know if you guys can handle 90 minutes of notes. Or am I thinking wrong? Do you guys have a preference? You would prefer notes the whole time?
No.
Oh, okay, I guess you got outvoted on that one. That's okay. That's okay. I understand it. Like, there's a reason I took the ACT day off. I have a lot of trouble just sitting there watching something for a long time in a row. Like, it's almost torture when I watch you guys take tests. It's like the worst thing ever. And ACT was a 4-hour test. I know I couldn't handle that. So I get your pain. It's hard to do this if you're not interacting, and my smartboard doesn't work anymore, so I can't have you interact. Okay, cube root of 27x7th. What I'm going to do is I'm going to start by breaking it up into numbers and letters separate. And like I said, this is what you'll eventually do in your head. And if you want to write it down every time, you can. Oh, that doesn't, what the heck, that yellow looks weird. Interesting. We want to break these up into perfect cubes if possible. So cube root of 27, that actually is a perfect cube already, right? And this is where you'd probably use your calculator if you weren't sure. So cube root of 27 is 3. So that's a perfect cube. So I'm okay just leaving that in. Now cube root of x 7th, well, number one, you can't even use your calculator on that, can you? But I do know that x to the 7th has some cubes in it. So what I'm going to do is I'm going to write this cube root of x cubed times cube root of x cubed. That was bad 3. Times cube root of x to the, what number would go here? First. Because my powers have to make 7. And so I'm going to break it up into perfect cubes, whether in my head or whether I actually write it down. Cube root of x cubed is going to be x. The cube root and the cubed cancel each other out. It's like saying the square root of 3 squared is 3. Square root of 9. You guys don't really ever say 3 squared. You say square root of 9. But cube root and cubed are opposites, and so they cancel each other out. So cube root of x cubed is x. And then cube root of x, well, I have no idea what that is, so I just leave it. If a root can work out perfectly, you do it. If a root can't work out perfectly, you leave it. That's kind of the goal of simplification. So my final answer would be 3x squared cube root of x. Now here's the part I semi-disagree with. Like, to me, that's not any simpler than the first problem, the original problem. Like, the whole goal of these is to simplify, and this bottom one is what's going to be called simplified on any kind of standardized test you have. Like MCAs, ACTs, AP test, if you ever take it. Like, the bottom one is what's called simplified, even though, to me, it's actually, like, worse than the original problem. But that's what you're going to run into. So if you are asked to simplify a root, this is what they want you to do. Okay, how about this second one? Sean, we need to get you woken up. Especially because you probably have like 3 other online classes today or something. This is probably your only real class of the day. No? Okay. If I have a root with division or a fraction, do you remember what I can do with it? So this was the property on the last page. So if we had two separate ones, we could combine them. But the exact opposite works. If we have a single one, we can take it apart. So I'm going to do cube root of x cubed on the top of the fraction. Cube root of 7 on the bottom. Okay. I wonder if I was supposed to write 27. Oh well, let's go with 7. We'll make it hard. Bless you. Now I'm questioning myself. I don't think you have to know how to do that yet. Well, let's just do the hard one. We'll start with it. Top. Top comes out to be x. Cube root of 7. It doesn't work out nicely. So we just leave it for right now. Do you remember how we weren't allowed to leave a square root on the bottom of a fraction? Like rationalizing, it's called. Mainly we had it when it was like 1 over square root of 2. I bet you did that in geometry. When you guys did sine, cosine, tangent in geometry. You're not allowed to write a square root on the bottom for the same dumb reason this first one, that's called simplified. It's just called proper form. What would I have to multiply that by so that it's going to be a nice answer? So if I'm doing cube roots, a cube root would cancel with a cubed. Right now I only have 1, 7. I'm going to multiply by 2 more of them on top and bottom. So the top of the fraction, honestly looks terrible now, is going to be cube root of 49 times x. The bottom of the fraction is going to be 7. And that's because I have cube root of 7 cubed. Just kind of curious, from 0 to 5, how about this last one that I just did? How'd that finish up for you? If you call yourself anywhere in the middle or up, that's actually plenty good. Okay, honestly, that's much better than I expected. Okay? Because they definitely get easier the more you do. It's just kind of really odd. Okay, here's some of them. See if you guys can simplify these on your own, just given random problems. The goal is to do roots whenever you can and to not when you can't. Let's Matilda, have you rolled yet? No? I feel like we have to give you this experience before you go back home. Even though it has nothing to do with America. We'll just pretend it does. Sure. I figure I'll kind of give people notice ahead of time so they can get help if they want. Oh, the triangle one is the one first. The number on the top is kind of how you read it. So the triangle pyramid thing, there are 3 numbers on the top. They're all the same. 2. Okay, so second row. 2, 6. 1, 2, 3, 4, 5, 6. Henry. Oh, you already have the answer? I was gonna say you're gonna do A.
Yeah.
I bet a lot of people aren't done. I was gonna give them a minute. I was just giving you notice in case you wanted help. Okay, second person? 2-5? I feel like you're rigging this. Munir, you are B. 2-4?
2-2.
2-2. That's bad luck. I'm sorry. You have C. Now, I wanted to give you some notice ahead of time in case you need some help and try to, people around you. Or are you guys just faster at these than I thought you would be? Let me see. I think we are. Oh, I'm sorry. What are you asking me?
Proceed.
Yeah, I didn't hear anything you said before that.
Oh, you put this, three root X nine.
Yes, and then simplify it from there. Okay, Henry, how about the first one?
So for the first one, you're gonna split it into 16.
4 through to 16.
4 through to 16 and 4 through to x to the fifth.
Okay,
And then you're gonna split 4 through to the x of x to the fifth into 4 through x to the fourth and 4 root of x. And then the 4 through x to the fourth cancels out to just be x. And then 4th root of 16 turns in is just 2. And then, yes, 4th root of that.
like that?
Yep.
Okay.
And then it's 2x.
Tell me. Okay, you want me to scroll it down? Whoa, we have answers on the bottom? Looks like I'm better at planning that than I thought. Or I remembered. I can't scroll down too far. Okay, so 2x, 4th root x is perfect. Did I have that on the other page? I wonder. Very nice, though. Munir, did you get B yet? No? How did you start it? Should we go with that? We'll kind of work it through together. Okay. How'd you start it?
I split it into 4 square root of, 4th root of x to the fifth,
8.
8 over 4th root of 3.
Perfect. That's definitely going to change your answer if you thought it was a 5, though, huh? I know my handwriting isn't always great. And it's very hard to write small. Okay. 4th root of 8. 4th root of x to the 8th. How do we break that up? So we want to try to break it up into 4 powers. So x to the 8th, if I break it up into 4s, should work out exactly with 2 4s, right? Okay. So 4th root of x to the 4th. Okay. How about the bottom? Does that work out perfect? Definitely not, no. So, since we're not allowed to leave roots on the bottom like that, which is kind of a dumb rule, but whatever. How would I make the bottom a perfect number? So if I'm doing 4th root, I'm going to want 4 of a number. Currently, I only have 1 3. So I'm going to want to multiply it by
3 others.
3 more of them. Now you can write them in a single root like that if you want. Like if that makes it easier. But we'd have to do it on top and bottom, which is annoying. In my opinion, you had the hardest question, Munir. You're doing very good. This one's probably the hardest. So the top comes out to be x, and then another x, so x squared. And then 4th root of 27? Yeah, that's 3 cubed. And then the bottom comes out to be 3. There's lots and lots of numbers in this section.
If you wrote it the other way, would it still be right?
Like the fourth row, 27 first? Definitely. Yeah, the order you write them at doesn't matter at all. I bet you most of the time they'll put the number first. Let's see what I wrote on the bottom. I wrote the exact same thing. Psh, it's like I was smart before, too. Drew. So you asked me what to start with it before, and what you said was perfect. The first step would be to kind of make them a single one so that you kind of know how it breaks apart. And then were you able to figure out it from there? That's okay. Do you want me to give you a minute? Okay, I will do that. The fan's running right now, so it's hard to hear that far. Yep. Yep. So most likely what's going to start happening is you guys are able to figure out what the answer is going to be without writing it down. And I'm okay with you doing that. Do know that if you need to write down all this stuff, do it. I mean, like, it's not a big deal. But if you can figure out something in your head that wouldn't need to be written down, you definitely are allowed to do that. Did anybody kind of figure out the shortcut yet with the letters? Like, what the heck? Like, I know the answer is going to be x cubed. Fourth root of x to the 8th, I knew the answer was going to be x squared. Did anybody figure out how to figure out the power right there?
Is it the number that would multiply into the?
Yeah. Yeah, I did 8 divided by 4. 9 divided by 3. And if there's a remainder, like this first one, 5 divided by 4 would be 1 with a remainder of 1. Like, you kind of figure out little shortcuts in your head after a little bit. But this one was broken up into cube root of x cubed 3 times, because that's how the 9th power came about. And this is kind of what I was talking about, where once you start figuring out in your head, like, shortcuts, you're welcome to use them. Do you want me to leave that up there for a minute? Now, 11:31. Should we stop here and do this tomorrow? Okay, we can do that. Friday. I meant Friday. Okay, now I do have the notes already uploaded, the blank ones. So you might be able to figure them out ahead of time if anybody like wanted to just go through. Yeah.
So would the homework be due Friday then? Because you're finishing?
Oh, for sure. It's not today. Yeah. Oh, I'm 100% not expecting anybody to be done with the homework. What I was thinking is I would just put up the homework, and you're only going to be able to do like the first half-ish of the homework. Yep. No. That's okay.